facilitator. Okay. Hi, everyone. My name is Josh Persi. Today, we're going through chapter 6 of DevOps for data science. This chapter is all about demystifying Docker. I have never used Docker before in my personal or professional life, so it's new to me. Catch me if you correct me if you catch me saying anything incorrect. And in terms of demystifying Docker, I don't know if this chapter for me really hit that mark. I feel I had to go to a different Docker tutorial to like get up to speed. And by the time I finished that tutorial, this chapter didn't like demystify anything from a data science context. So I've kind of interwoven some stuff that I pulled out from the other tutorial and to try and make a more fulsome attempt at demystifying Docker. But we can dive right in. So these are the learning objectives from the last iteration of the last cohort. Let's see if they still apply. Decide whether a container is the right tool for a given job. Sure, we'll cover that. We will learn how to download and run pre-built Docker images. We will learn how to describe the stages of the Docker lifecycle, and we will hopefully learn how to build simple Docker files for our own projects. So why does Docker matter for data science? It comes down to a few things. Not all of them are listed here, but these are the big four that came to my mind. Docker creates standardized environments that are reproducible, portable, collaborative, and scalable. I think of Docker as like the next level of reproducibility after RN, or virtual environments, which are environments as code. Docker is kind of like almost infrastructure as code, or a deeper level of setting up a standardized environment, because you can go all the way down to the operating system and ensure that your team is working on the same operating system with the same dependencies built on top of that OS. So that is one aspect of reproducibility. Also, over time, for example, if you're a Windows user, you might have written a project in, I don't know, Windows Vista or some other older version of Windows, and you've upgraded over the years. If there was some sort of link between how your code ran and the Windows operating system, I'm not exactly sure what an example of that might be. I have no lived experience with it, but I've heard people say that the type of operating system you use can affect the output of your analyses. You're kind of in a bad situation there because you don't have access to the older version of Windows. If you use Docker, you can make sure your analysis runs on a free and open source operating system like Linux, or like a Linux distribution, and run that analysis kind of in perpetuity, regardless of how your host operating system changes over time. Docker is also portable. By portability, I think of the fact that I can develop something on my Docker, on my local machine using Docker, and then I can use that same Docker image and deploy it, or get my IT team to deploy it to a production environment. So it can more easily, so I can more easily work in the environment on which my product will eventually be deployed, whether it's a Shiny app, an API, a report, something else. Docker is collaborative. Everyone can work from the same image, ensuring a similar, or actually the exact same environment. And Docker is also scalable. This is another thing I think about when deploying something to a production environment. I don't have any lived experience with it, but hypothetically, you can deploy multiple instances of the same image as different containers to more easily scale your application to a broader user base. I'm just going to take a quick look at the chat in case anyone has any Okay, great. Feel free to jump in on the mic if you have questions or you want to add something.
No, like I think it's maybe we should mention Podman here, which is like so Docker and Podman are compatible. People are moving slowly to Podman,
Oh,
but
okay.
if you learn Dockers, like since they are compatible, and if you run Podman, I mean, if you run Podman on Docker, it's gonna work. And I have not tried other way, but it should work too. Um,
So Podman is like a competitor or a like successor to
it's
Docker in a
it
sense.
it's a successor, but like I don't think it matter much for like a data science perspective. It's more for an architecture perspective because
Okay.
sometimes Docker need to it's need to run at the root of the permission. While this is not the case of Podman, Podman is generated by the process that's called Podman. So there's like,
Okay.
I think the difference is mostly in the architecture space and less in the reproducibility space. Maybe it's good now to mention the virtual machine and the difference between the virtual machine and Dockers. I think the main difference is the Docker image should be immutable. While you run a virtual machine, you can do a bunch of stuff and recall the virtual machine, and it you have basically like it's like you're having your operating system and you install a bunch of package and nothing is tracked. I mean, you can do that. Why not? While Docker's like this, the image should be like it's guaranteed to be the same. So that's maybe helping people
Hmm.
understanding like, oh, so I want a VM if I want to play around. But if I want something to be like immutable, like I want something like to be fixed, then Dockers will be a bit different, for example. Even if you
I think that's great. A great addition.
And also, just to jump in, like one quick thing, I guess in the enterprise context, you have to pay for Docker. Podman, at least for now, is free.
Okay.
Um, and then also, I guess if you have a Linux leaning enterprise, then since Podman is developed by Red Hat, presumably if you have like a Red Hat kind of support license, it might extend to the Podman stuff. Yeah.
yeah, I think this is a great point.
Interesting. Interesting. Uh, Kind of tangential, but Red Hat that makes a Linux distro, or
I guess it's IBM now, but anyway.
Yeah, no, it's IBM. But yeah, Red Hat is the enterprise version is called RHEL, Red Hat Enterprise Linux. And their kind of desktop version is Fedora, and this is also like their bug training ground. Like so, basically, like they provide Fedora as a Linux operating system based, while they debug, and then they provide to enterprise the result of this debugging in Fedora into RHEL.
okay.
And I
Okay.
think we are in Fedora 43 or 42, and RHEL is I never know 8 9. Anyway, yes.
Interesting. Um,
And no, it's CBM, yes.
okay. Good to know. Good
Praise,
to know.
praise the overload.
Last reason Docker matters is because they have a great mascot, a whale. Maybe one of the best in the biz, I would say. R is just a letter. Python's a snake. This is a cute whale with containers on its back, which makes sense because Docker uses containers. It's one of the key kind of things in a Docker ecosystem. So to keep on rocking and rolling, what is Docker? It is an open source tool for building, sharing, and running software. There are four, I suppose, things that might be new to you if you've never like talked about Docker before. They are the Docker file, and we'll discuss these a little bit more, but just to provide a brief introduction at the outset, these are the Docker file, which builds a Docker image, which you use to run a particular instance of a container. And you can push your image to an image registry, which is to me analogous to like GitHub, except I suppose instead of hosting source code as you would on GitHub, you are hosting like a immutable snapshot of your environment aka a image. So let's go through some of those steps one by one. The Docker file builds Docker images, but as far as I understand, it is also built from Docker images, just more broad general purpose images. For example, this is an example of a very simple Docker file, and you are pulling from the Ubuntu latest image to build your own image, which is the point of a Docker file, to build an image. So if we wanted to find out more about what this base image we're pulling from is, we can go to Docker Hub, which is our image registry, and we can look up Ubuntu, which is, of course, the most popular, I suppose, distro for Linux. And you can find the Ubuntu image. And I haven't gone through these pages on Docker Hub a ton. I don't know what sort of useful information you can find out here, but presumably if you had the need to, you could find out what exactly is contained within this base image. I'll tidy up some tabs here. So a Docker file is just a plain text file you can make in any IDE. You first start with a pull from your base image that you want to use. You can then use several commands from run, copy, cmd, and others to establish your particular environment for your particular project. In this case, we're copying some data from a mydata.csv file from the root of your host working directory to the data directory of the container once you actually run this image through like the Docker run command. But right now we're just essentially providing a set of instructions for Docker to execute when we run the container. And then we have a simple run command. I think this is just like a bash command. So you could do other bash commands, I believe, to, in this case, print the first few rows of the data CSV. There are more complex things you can do here, like setting up entry points or ports, or running other commands such as like pip install or other command line things. The last thing I think I have to say about specifying your environment via Docker file is you could get a very bare bones Ubuntu image and then like write commands to install R through the command line or install Python through the command line, although Python I think comes with Ubuntu. But you also have access to a broad suite of pre-assembled images for data science. So you can, for R, I know Rocker. I don't know if that's an organization or like a code name for, is Rocker an organization or just a convention for naming things? But
I think it's just a group of people that's decided to build, like, to organize themselves to provide it.
Okay, gotcha.
I don't think they have like a legal structures.
Gotcha.
Yeah. But they have a website and they maintain it.
Okay, cool. Good to know. I know, at least in the R world, the Rocker images are frequently referenced. So you have images that add some kind of additional base components, base bits of software. So for example, the Rocker tidyverse presumably installs like the tidyverse functions or just the tidyverse meta package on top of whatever operating system it is built on. I don't know how to find that out, but it must have some sort of Linux operating system. Linux AMD 64.
That's a really good question, Josh. Is like how do you know, like, if you have concerns about, let's say, what is it, like supply
I think if you're
chain issues, like how do you know how they built the image? Like where can you find their Docker file? Like
on
the
overview, you have the link here. Yeah, I think this is
The
the
image was
image.
built from.
Yeah, look, and you have the script somewhere. Uh, yeah, look some Docker file, and here you are.
Okay. It looks like they're using Ubuntu Noble.
Yeah, which is the 24.
That's
So it's,
Ubuntu 24, like version 24.
yeah, that's the last
Okay.
long-term release.
Okay, so just as a exercise, you could go to Ubuntu. I guess those are just recent tags, but there are, oh, there's Noble. So if you wanted to in turn, I guess, find out what Ubuntu Noble has in it, you could like, I don't know when you would need to do this, but you could hypothetically, I guess, go all the way down to see how your like basest of base images was being put
I
together.
mean, a good example, like, is because you mentioned add, like the command line add that's produced. I don't never remember the number of first line. It's part of GNU core util, which is like binary provided by GNU. I never know how to pronounce that in English too.
Yeah, good.
But like right now, like there is a small drama because like they are rewriting it Rust, and the 25 release of Ubuntu use the Rust rebuild, and it's breaking. So that's an example of how it can, like even a simple command right now can become tricky. That's why like
Okay.
it's not on the long-term release.
Gotcha. Interesting. Just to wrap up about images and like I guess the Rocker program, you're probably best pulling in most cases from like a standard Rocker, at least if you're an R user, set of things. One that I've heard many people applaud is the geospatial image, because installing like I forget the names of these Linux packages, but the
GDAL.
GDAL and
Yeah.
like lib2d something can kind of be additional work at the very least. So using geospatial, Rocker geospatial, for example, will just like hopefully give you something that you can start using like SF and Terra and other R spatial packages with. Okay, so that's environments. Sorry, that's Docker files. They use images to build images, although I don't think most diagrams show that. They just show them building images. The next part in our Docker lifecycle, moving from a Docker file, which you write in for your particular project, are the images. These contain all the software that you bundle in your Docker file. So the base image and anything else you've installed, or any other packages or software you've installed, and any data you may have moved in to that particular image via the Docker file when the image was created. Because they are snapshots, you could hypothetically have a image as like the only thing a fellow colleague or a user would need to use to run your product if you decided to bundle your data with that image and all the packages to run that image and commands to run whatever output you wanted executed. You could hypothetically just send someone a fully fleshed out Docker image and let them run it to like produce a Shiny app or produce a report or do a job, which I think is kind of interesting. You can share your images. So you can, if your team is trying to use Docker and you have a particular environment you're trying to set up and share with your colleagues, you can create your Docker image via your Docker file, and you can put that Docker image up on a registry. Again, those are kind of like Git repositories at GitHub or GitLab. You can put those onto Docker Hub, which is, I think, the most popular, but every big cloud platform, Amazon, Google, Azure, has their own particular container or image registry, excuse me. So if you need to like make sure it's not shared with the public, you can look to those options. That's all I had to say, I think, about images, because I kind of talked about them a bit more on the last slide. Jump in if you have things you'd like to add. So,
Yeah,
go ahead, Ollie.
just maybe like so let's say like you have a project and you have a specific installation that's not like, let's say like the geospatial, you want another package into like the Docker geospatial or Docker geospatial. You're gonna basically you can use two ways of sharing it. One way is like creating a specific image, new specific image. Like the first one is building your Docker file, which is gonna build a specific image that you're gonna update to a registry. And the other way is sharing the Docker file from the Docker, where like then you're gonna like the people who you are sharing the Docker file are gonna pull the Docker from the somewhere, a registry, build it, and then they will have it locally or on the computer that's supposed to do the compute. That's the two way I think exist, no?
Yeah, thanks for adding that. I think that's a valuable addition, and this is maybe the stuff I was hoping would be covered more in the Demystifying Docker chapter. Like, what is the best practice? Like, both technically work, but what is more popular? Like, when would you use one or the other?
I mean, I think it's depend of what your company paid for.
I guess, yeah. If you have a registry, you might as well use it.
Yeah, and like basically like, because like rebuilding, like downloading the image is gonna cost you something. And then like that basically means you will have the image on your local computers. Image can be voluminous, especially if you build multiple of them. So so yes, and if you do not have, like, you go the other version of it, like I'm download the image, I build it locally, and the other trade-off I will say is like if that image need to be run into a specific environment, let's say like GitHub Action, I have no idea, whatever like your cloud provider provide, there will be also cost by like what are the costs of pulling the Docker image from somewhere. They probably cache it and then rebuild it, or versus the cost of downloading the image you have built. So here we go more into the cost of, but I think this is outside of the data scientist question. This is probably like a question like your IT guy. It's the IT guy in the book should answer. But I think this is like the various trade-off. At least I see.
Yeah, that all makes sense to me. Okay, good to know.
Because that could cost money.
Yeah. Yeah, figuring out how much money things costs is always, if you are also your IT person, I guess, as at least I think is the case for me. It's like I don't know how much these things cost. I don't really know how to find out. I wish I had an IT guy to kind of pass the buck to, but I digress. Okay, so if you think back to that original graphic that I pulled from the textbook, we have our Docker file, we build images, we optionally push those images to a registry. We're probably pulling images, our base images, from the public registry. Now it's time to actually run our image, and we run our images. When we run an image, we say we're building a container. Container is a useful word to use because, like a shipping container on the whale's back from that Docker logo, these are like sealed by default. They are sealed, isolated instances of your image. The book uses instance and container. I think the book prefers the term instance, but I think generally a container or an instance refers to a particular instantiation of your image that may or may not be running at any given time. So a container is running based on the image you specified, which was built based on the Docker file you specified. By default, they are ephemeral, meaning that anything you change within your container is all those changes are lost when the container shuts down. So they are ephemeral. That means they're pretty good for development because they force you to basically enshrine all the changes you want either in the Docker file or through some additional commands you can make, like setting up volumes. Volumes are, I think, a general term in computer science for like a disk or a partition on a disk. If that term is new to you, that might be helpful. But when we say we want to set up a mounted volume or a shared volume, Docker has a few different types of volumes, named volumes, mounted volumes, but I think the one we're most interested in is a mounted volume, where we are telling Docker to we're telling the Docker container to use data from a directory on our host machine, like the physical machine we have in front of us, to use the files within that directory within the container so that the container, when it's running, can access those files and persist any changes that are made within the container back to your host machine. This is not the default, as I was trying to articulate with the container metaphor. Your container is fully isolated. It's like hermetically sealed. Nothing's getting in or out unless you specify a volume, in which case your container can be aware of your host machine's file context and can like read and write to it, which is useful if you, I think I'm most excited about mounted volumes in the sense that I have a Docker container and I want to share the data I'm using for an analysis. Within that, I want to have that data accessible for an R script within my container, but I don't want the data to live within the image itself for security reasons, for size of the image reasons. That's how I think I would use a volume the most, and to get any output, for example, back onto my local machine so I could share it with my business stakeholders. Yeah, Umair?
Yeah, about the mounted volumes, I was thinking how would that work in production? If you want to use a mounted volume, where would we put that folder?
I don't know. I have no lived experience with using really Docker in general, especially Docker in production. My first thought is maybe like, do you use a different kind of volume? Like I know there's named volumes, which I think don't require a folder on your specific host machine to like share data to. But this is at the limit of my understanding. I would defer to anyone else who has better ideas.
Yeah, it will depend what you mean by production. That's that we go back in circle. Like, if your production is a servers that you control, let's say like an EC2 instance or even an on-premise machine, the Docker will live on a virtual machine, or it will live on the operating system of the servers. And then you can like change the mounted, or you decide to mount the volume or the file system to the specific. Let's say like it's on the data is on the servers is on home users servers data, and then the containers will see it as data. But that's mean like you need to adapt maybe your Docker files to it. And you can, I don't remember if Dockerfile allow you to set parameters or variable, but I believe you can, yes. But it could be wrong. So you can like, instead of having a specific path, you can save the path as a variable and then change it at the top.
Mm-hmm. I think so, yeah.
I could be wrong, but I think this is how I will solve that.
No, I think that's right. Like I've seen Docker volume commands where they do like print working directory to like as like the root of the file path. So you don't need to specify the absolute file path. They just say like whatever the current working directory is, look in the pwd command output with like the data folder concatenated to that file path. Yeah, I don't have any better explanation for you other than the suspicion that Docker is flexible enough to handle basically whatever production architecture requirements you have. So hopefully there would be a way to satisfy whatever architecture you have.
Yeah, usually also at that point, if you go like to full production scale, you will use Docker Compose, which is like a way to composing multiple Dockers. And then like we move away from data science and we go more into architectures. Where like you usually will have like a Docker for databases. And the Docker, like doing the analysis, will be like also in this Docker Compose file that's gonna call the specific Dockers that have the databases. Here we are like building a whole bunch of boxes. But yes, this is how I have seen it. I don't know if it's, but I feel, except like in a lot of cases, usually like you're gonna use, I mean, I think maybe I could be wrong, but what I have seen is like we are drifting away from that, where like the cloud provider is going to provide you as a Lambda function on top of your AWS RDS. Like it's going more and more through like this Docker Compose file is going more and more into like services that's provided by cloud versus like fully architecting it yourself. I don't know if that makes self clear, but that could be just my impression. I don't know.
Okay, we'll keep rocking and rolling. It looks like I'm close to the end of the slides here. Oh, that is my last slide, I guess. So how much time we got left? We got about 20 minutes left. That is kind of what I don't know if there was anything else specified in the chapter that really shedded any light on how to use Docker beyond, I think, what we've covered here. Does anyone have any other idea, like anything else really resonate with you from the chapter?
No, I agree with you. The chapter was bland. Like I mean, it was not bland. Like what I really like into the chapter was the appendix. Like if you go into appendix D or whatever the name of the, and you have all the commands like that, and they are useful. I would like it. Like it's to, I mean, it has plenty of commands like that are useful, and maybe like the format is maybe not perfect, but I think this is useful. One that I see that's missing here is like Docker can be voluminous, so sometimes you want to prune your old image so you free spaces on your disk.
Yeah.
So I think the command, like one stuff that I would like to mention that's not mentioned in the chapters is Dockers is kind of Git in the user interfaces. So that means like Git, you can do Git a command and some arguments. Docker is similar. You do doc, like for example, you have Docker pull, Docker push, Docker run. So it's Docker / the commands. Like some other command line interface tool, let's say like are using 2 letters. Let's say like stuff to build file system, for example. Like they're gonna use like they have another, and more I see more and more tool developed that way. So you have like the name of the kind of like meta program, which is Dockers. And then you have the binary separated, which will be like the binary for run, the binary for, and then you can, and so this is something like to keep in mind. Like it's similar to Git, similar to other tools, but not all of them are like that. So it's just a design perspective that when you are confronted to this kind of tool, it's good to know like for the users, this is how you access it. So you have like these 2 words, then a bunch of argument and flags.
Mhm.
That's one point, like just to keep in mind. What do I write also?
I have a question
Yeah, go ahead.
about caching the commands. So the chapter mentions, and also in my experience when making Docker containers for Shiny apps, I see that locally when I create or recreate the Docker image, it doesn't take a lot of time. Most of the commands are already cached. But when I deploy it to something like Google Cloud Run, it always takes the full duration of building the image every time. So I'm not sure what is different in the production environment that makes it run from scratch, or if it is only specific to Cloud Run and other services allow you to cache the Docker commands. What is your experience?
Similar to yours. I think one point, like also that's like what's on your computers is not a registry. The registry is the remote parts, like unlike Git or GitHub, where what is in GitHub is like a blank copy of what is in your computers. The Docker registry is different. It's more like a server of image, while what you build locally can have cache stuff. And to answer your question, I think it depends of the service you use. Do they allow you to cache? And I think, for example, GitHub does that sometimes while doing GitHub action.
Yeah.
But not all of the services are doing that. And I don't know. And sometimes not even the same services do it the same way. And I can't explain it to you because that's probably depend on a bunch of services, no? And how do they, and what's
Right.
your do you have like an enterprise account, a free account? Do you have like what's the billing? I mean, what's the account level you have also may change that. So yeah, it's a tricky question. Like I think the answer will be like to build, like if you want to avoid that, it's to build your own image. Let's call it like, let's say like a humor shiny app number 2 or whatever, and send it to a registry. Then maybe it's faster, but then you're gonna pay the registry fee in a lot of cases.
Yeah, I generally just use the golems command to create the Docker file and then deploy it using, again, its own command. So it goes directly to GitHub, and then the image is taken from GitHub from Google Cloud Run, and it then builds on that image. So I'm not sure what happens in this pipeline where every time I push the Docker file, it would start from scratch, and the previous commands like installing the OS and installing R, all of that goes through step by step every time. So it starts from scratch.
But when you say like it starts, is it like the GitHub? What's starting?
On Google Cloud Run, whenever a new container starts, actually not the container, when the container is being built from the image, it goes through all the commands for the Docker step by step every time. So as the chapter mentions that once you rerun or rebuild the container, it should cache all the previous commands. The only new thing that you add to the Docker file, only that will be the thing that will run. Everything else should be cached. So, but that doesn't happen when I use Google Cloud Run.
Like I think it's normal behaviors, because if you modify your Docker files and if there is difference between the previous Docker files, you need to rebuild because something have changed. And I don't know how do they monitor the fact that the change is meaningful without running the change.
Doesn't the way it work, like you kind of like have different layers in your Docker file, and then so basically everything that's below a change gets rebuilt, but everything above that change is presumably cached. So like it seems like there should be limits about what's being rebuilt in Umer's case. At least that's my crude understanding. I could be wrong, I could be right. Another
That's
thought
my
is,
understanding
which is
also,
actually a
yeah.
question, is like for a Google Cloud run, I'm not familiar with it. Are you working with like a single like virtual instance, or is it do you get provisioned like a virgin instance every time you interact with it? Because if it's the latter, then it would make sense that everything gets rebuilt because it doesn't have a cache. There's,
Yeah.
it's like it spins up a machine for you, you pass something into it, it builds, and then your next interaction, you get a new machine. It garbage collects the old machine and then you get a new one. Anyway, just some random thoughts.
Yeah, I think the latter may be correct for Google Cloud Run because it says that it is stateless. So it probably is, yeah, I think that's what's happening.
So I think with like
So
AWS, you could get around that, or at least some of the compute instances. There you have like a file. You have a file system, permanent file system.
yeah, in EC2 you can like specific a block file that you kept, and then when you remount the block file to the EC2, it can be kept.
Great.
But I don't know if we will keep the cache. Yeah, good question. Like this will start to become tricky, and this is why vendors make a lot of money too. Because like yeah, it's difficult to have like all the layers, having an understanding of all the layers. But it's important to understand like the difference between what's inside of your compute and what's the registry, which is different. And I thought like at the beginning when I was reading like, oh, what do I have in my computers? It's the registry? No, it's not. It's another. I mentioned it, but you should run docker prune. I don't remember the exact command, but like sometimes because you could have like very old version of some stuff that's take a lot of money. Space.
Okay, does anyone have any, oh, sorry, go
Yeah,
ahead.
I have a quick note. Like I mentioned, like a Docker image is mentioned by an ID, and then you have a tag, which is usually the version. But sometimes you have also like specific tags. That's, for example, the devel version or the latest. That's two that at least I know, or at least I have used in the past. The latest is because like I'm lazy, but it shouldn't be correct because like it can introduce subtypal bug. Like if you pull the latest and then someone will pull the latest and not the same. So maybe it's better to pin the version. But devel is good if you want to test on the devel, but it's more like, hey, I have these fixtures. I want to know if it's gonna break in the devel release. No, the book, like, yeah, I agree with you. Like, I think I learned more Dockers going through the link provided by the book or going through the Rockers pages and testing stuff than going through these chapters.
One big missed opportunity that I think points to my noob level understanding and experience with Docker is how to use Docker as a dev environment. I was kind of wondering if anyone has any experience with that and how you do it. Like in particular, I see there's a command here, but I don't know if it does what I want. Like, so let's say I have my Docker file, everything gets spun up. I have a running process on my computer. How can I attach to that and work interactively in it? Is it really just Docker attach, kind of like you would like tmux, like you attach to a session or you attach to like a process? I'm wondering how that works because it seems like that's a hugely appealing use case that I'm surprised the book didn't go into.
That's a great point. One way, like the easiest way is running it on interactive, adding like TI, I think, or something like that and then you start an R session. But or can, like, for example, I use RStudio or VS Code to connect to this station and running it. I think it's possible. I don't remember how, because it's usually when I do that, it's more like because I usually have Postgres of local machine, but I not necessarily have MySQL or a bunch of other crappy databases. Sorry, MySQL. You took like a bullet from like not for everyone, but like I want to test something. And usually I'm gonna run that as a services. The Dockers will be like, and then you can specify the port that's matched to the Dockers the service you are merging. Similar that and this is one of the missing, I think what you said is correct, like it's missing bullet from these chapters, is how you decide to run like this Dockers as a services that you can go and then you connect like services with a specific address because you have a port on your local machine. That's our matched to somewhere. So I think this is part of the answer, but it's probably not the full answer. Like because like our user may want to have like I'm pretty sure like some cloud services provide you that. You can specify a Docker version and run everything, but I don't know much about them. But I agree, like this is a point like let's like we can finish earlier, like, but yeah, I agree with your critique. I think this chapter does not go far enough. I think it does a good job of sure, run Docker is gonna work, but like for example, if you have never installed Dockers, this is already a huge challenge for plenty of people.
And you're on Windows.
Especially on Windows, and on Mac it's similar, like it's crap. It's only and because like in Mac you need to remember like to run the Docker as a services, or if not, like yeah, which it makes sense, but like it's can like so either like you go like very beginner friendly and like you explain, hey, on Windows you do that, hey, on Mac you do that, hey, on Windows you do that, on Linux you do that, or on Linux you go deal with it by yourself, or you abstract that and say like, oh, you already have Docker installed, this is like the few commands that's very useful, and maybe go to some use case like, hey, I want to run my script on Dockers, what do I do? Or I want to run my Shiny app on Dockers, what do I do? And the book is kind of letting you do that in the lab, I feel, because like the lab exercise, I want to have my model run and with my API call on Plovers, or I don't remember, run on Dockers. But yeah, I agree with you. I don't know what
In
was
fairness
thought,
to the
but yeah.
book, though, like I kind of feel like one issue is maybe I'm wrong on this, but it feels like the environment. I think it's a real challenge with this book. It's like how do you create something that is of lasting value, given that the IT world moves so quickly, right? I mean, already I wouldn't say Docker is deprecated because lots of people use it for very good reasons as a great ecosystem, but Podman is on the rise, you know. And then, you know, for the like, how do you connect? Maybe when Alex wrote this book, there weren't good hooks in VS Code. Now there are. Then there's also like was it DevPod? Is that what it's called? That a lot of people use. I don't know quite. I don't think that's quite Docker, but that's a really appealing option too. So all that to say, like the landscape, the ecosystem changes so quickly that if you commit to something, it's going to have a shelf life.
Yeah, that's a fair point. But I think what it's important is it's true like Docker's, like you can still run use Docker image in GitHub Action. You can still like there's plenty of infrastructure that integrate it. So I guess if we go back to the learning objective, I think we match them kind of. And then the practice, yeah. Depend how far you want to go into the IT places, if you need to go or not to go.
Then draw the rest of the owl, right? So
yeah, then draw the rest of the owl. That's the 100. That's a totally good analogy, I feel. I think it's similar if you look into like the book are in production, but still in building. Like I tend to go to this book and the two of them like in the same places. The book is using as a POSIX Connect, and I don't know how POSIX Connect works exactly, but our GitHub Action and both rely on, I mean, at least GitHub Action rely on Dockers and a set of parameters inside of the GitHub Action, a set of steps. So maybe, but I would say like maybe it's better to start on Linux or Windows servers to do that instead of using two vendor specific option. That's but this is like the pain we are right now. Like a lot of stuff are vendor specific, and do you want to learn the vendor specific, or do you like what's the trend? Like it's hard to decide which way you are going.
And naturally, if you go the vendor route, it's so much easier to start until you get locked in and trapped, and it becomes hard to pivot, which is exactly what the vendors want.
Yeah. And then you are on Slack and you need to pay a lot of money to keep your Slack history. Anyway. Well, it was nice, everyone. Thanks. Hopefully I will be able to join next week. We'll see. So
Okay.
I hope someone want to continue facilitate this book. Maybe it will be me, but I'm not sure. So
Do we have someone signed up for next week to present?
yes,
Or
yes, yeah.
Okay.
We
you
could
just need
like for a
someone-
month. Yeah.
If you just need someone to like
And someone to
when they
start
come in and
start and
that's easy.
end.
Like we can totally do that.
Cool.
Since Arthur's on video, Arthur, you are beholden to remind me if I forget. Umair, you have to remind Arthur to remind me if you're on the call.
Cool.
We'll actively figure it out.
Perfect. So well, hopefully see you next week, and have a good weekend, everyone.
Sounds
Bye.
good. Enjoy the
Bye-bye.
first day at the new gig. Take care.
Yeah.
Thanks so much.
Bye.